Hi everyone, I am Matheus Santana, Vice Leader Team and Project Manager from Capital Rocket Team. The Daedalus II mission was divided into 5 main areas. Each area has a specific task in the project subsystem. The project schedule began in July last year. It went through the MCR, PDR and CDR. Subsystem description: hybrid propulsion. We use as propellant pair paraffin and nitrous oxide. The total mass of the empty system is 7.7 kg and the propellant mass is 2.9 kg. Flight performance. All the simulation we made with 5, 10, 50 degrees of launch angle and 2, 5 and 10 meters per second of wind velocity. The fins were designed to let the stack imagine between 1.5 and 2 calibers. So the center of gravity is 147 cm from the nose and the center of pressure is around the 172 cm of the nose. Structure. The rocket shell is divided into 3 structural modules, whose total length and total mass is 2.2 mm and 8.9 kg made by fiberglass composite. Avionics. There is a module in the launch pad for a valve, actuation and store data from the filling process. The second system, responsible for the rocket telemetry, transceives to send data to the base, a parachute ejection, a bus and GPS for the rocket location. Recovery. For the recovery system, will be used turbo implementation for a parachute in the same module. The ejection system will be pyrotechnic using the gunpowder. In the figures, you can see the propulsive system, the tender descent mechanism from the recovery system, the injection chamber, avionics modules, and the stringers. The team performed several CFD simulations. For example, in the figures we have a 3D external ballistic simulation and 2D parachute simulation. The team also performed several finite elements analysis. The following images show the flutter simulation on the fins, buckling on the modules, pressure on the combustion chamber, and the simulation on the launch pad. The team also performs avionics simulation. These were made of a critical system such as the interceptors and the ignition system. The image shows the simulation of the ignition system. After designing, a blow analysis is developed for several cases. They are testing according to the cases that are most likely to happen through a fire test or launch, using previous projects as reference. The blowdown analysis provides the parameters shown in the table, and the thrust curve we used to run flight simulations. Following thrust curve, that it was possible to simulate several trajectories and the stack imaging during the flight. The simulation showed that the rocket is not safe for launch with a wind velocity above 5 meters per second. However, the average wind velocities at the launch site are around 2 meters per second and are hardly ever above 5 meters per second. Besides, the impact dispersion simulation showed that the rocket will not fall at the risk area. The team assembled the risk matrix of each subsystem. Here is a list of some possible failures. We see that after mitigation, the risks are medium or low. Preliminary project budget considers only materials costs during the construction until the testing phase. Most of the team's expenses are with propulsion system due to the cost of the oxidizer. The structures also have a high cost to the price of the materials used to the manufacturing the rocket. So thank you for watching.